Okay, welcome, welcome. This is the week 3 webinar of the online stats class. And I thought I'd talk about what we're doing as always. I'm always happy and encourage you all to ask questions, and I'll be happy to do my best to answer them. So, please be involved. That's one of the big points of the webinar is to allow it to be, interactive and me be able to get back to you immediately instead of if you email me, it might have to take hours. So just let you know, I'll answer any questions you have. Then I'm going to review. We talked about it, but we didn't, that you may not remember. And that is the definition between a discrete variable and a continuous variable, because that's what we're talking about today. Then we'll get into probability distribution tables. So given values and probabilities, make a table. Then we're going to get into what's called the expected value and the standard deviation. So kind of really important when you're trying to figure out, whether you what you want to do and whether something's worth it and what's going to happen, that kind of stuff. So I'll go into the details of it. Then we'll get into the binomial distribution. Then we'll get into continuous distributions. And the main continuous distribution we're going to work on this week is the uniform distribution. Turns out that's the only one that is not that hard to do by hand. And then we'll talk about the mean and the standard deviation of the uniform distribution. So that is the plan. So I want to give you a couple of heads up. The first is this is week 3. Week 3 is odd. What does that tell you? So 3 is an odd number. Yeah, no exam this week. Okay, it doesn't mean you have nothing to do. In fact, what I strongly recommend is make significant project progress on your project one. So again, please post your project one ideas on the project one discussion board, and I'll let you know if it works. And in what I'm hoping you post are your your survey. So what is the survey question you're going to be doing? What's the population of people? And what is your plan for getting a sample? What technique are you going to use and how are you going to use that? And who your client is. So I strongly recommend you post that on the Project One discussion board so that I can let you know whether it works or not. Okay, and I could also let you know what you need to make adjustments on to make it work better. So that is, should be a big focus this week is getting that project progressing with your project. Okay, don't wait till the last minute. Okay, this is really the time to be working on the project. So that's a main thing. Any questions at all about anything? Always happy to answer questions. Okay, if there's no questions, feel free to ask questions as we go. I'm always looking at the chat box. And I'm going to go through and talk about chapters 3 and 4, which aren't that hard chapters. That's why we can do two at once. But there's work to do. There's some definitions and templates and stuff like that, which we'll get into. So first is a reminder of discrete and continuous variables. So a discrete variable is a quantitative variable. So that means that the, the data that you're going to be writing down are all numbers, bunch of numbers you're going to write. And the set of possible outcomes for each data value can be displayed as a list. Okay. So that list might be 1, 2, 3, 4, and 5. That could be examples. Could even have dot, 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 but it can be displayed as a list. Quantitative variables that are not discrete are continuous. Okay. And those are the ones that there's no way you can display as a list, even with dot, dot, dot. You just can't do it. It's just too much. So that we'll do examples, by the way, today. So, but I want to remind you of the definition. And in particular, for a discrete variable, you can always create a probability table. Okay. Whereas with a continuous variable, you can't list them all. So good luck making a table out of it. So one thing in grammar is the question how many will just about always work for a discrete variable. So let's see if we can put the chat box a survey question that would give you a discrete variable as, the data. See if you can put a question that you would ask someone. And let's see, I'll take a look. There aren't too many of you here, but hopefully you can type it in. So type in a question that is a question that relates to a discrete variable or that has a discrete variable for its answer. It turns out how much is more of a continuous variable. Okay. It's a little complicated, but if you hear how much, then you'd be thinking continuous because you can't really list every possibility. Yeah, how many items will you buy? That is a discrete variable. Okay, so again, the grammar for discrete is more of the how many. The grammar for continuous is how much. Okay, so another example of a continuous variable would be things like how much time did you spend in the shower last time you took a shower? That would be continuous. You can't just list all the possibilities because it just goes on and on and on and on and on. You could, you know, I showered and it took me maybe 603.507214 seconds. Do you see? So that would be a continuous variable. Okay, discrete variables are more the how many things like how many siblings are in your family. Okay, how many items do you buy? There's a lot of discrete, and they're both important. Any questions on the idea of discrete versus continuous? Okay, so now let's do an example where we're going to actually work things out. Okay, kind of a somewhat real life example. And that is the following. A car salesperson gives out a $10 gift to every customer who test drives the car. That's a typical thing that happens sometimes, right? Hey, you come in and check out our car, we'll give you a gift. Okay, and it's going to cost the salesperson $10. 12% of all customers who test drive a car purchase a base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay? Okay, and by the way, what do the rest do? What do most people do when they go to a car shop? Any thoughts? I don't see y'all jumping in. Most people don't buy a car. They come in, they say, nah, thanks anyway. Okay? And that can happen. Yeah, leave without purchase. Okay, so what we want to do is, again, we want to think about as a car salesperson, is this a good job or not? What kind of money are they going to make? Does that make sense? So let's look at the profit. So notice that every person is going to be getting a $10 gift, and the commission could be 200 or 300 if a car is purchased. So if the $200 car is purchased, in this case, the profit will be $190 because $200 commission minus a $10 cost to give the person the gift. Similarly, if the customer buys the deluxe model, then you get the $300 commission, but you still got to give the $10 gift, and that's $290. Hey, most people don't buy a car and they get the gift. So that's going to be a negative $10 profit. So it's a loss. Any questions at all on the list of profit values? Any questions? Okay, so now what I want to do, we found the values what we call X. X will be the outcomes that could happen. Then there are the probabilities. We've seen last week, we called them P of X. If you have a 12% chance, they're going to purchase a base model. Don't forget, probabilities are decimal numbers. They're not percents. So you need to turn 12% into a decimal. You move the decimal over twice, and you get 0.12 for the probability of a $190 profit. Any questions on how I came up with that? All right. There is 8% of the customers do the deluxe model for 300. That's a $190 profit. Sorry, $290 profit. So for the $290 profit, it's 8%. Don't forget you move the decimal two places, and that's 0.08. Any questions on that? Okay. Now we want to find out the probability of a customer not buying anything, leaving without purchase. So the key on this is that the total probability is always equal to 1. So if you add up the numbers, you get 1. So 1 is equal to the first probability, 0.12, plus the second probability, 0.08, plus the third probability, which is the one we don't know. That's the probability that x is negative 10. We don't know that number. But what we can do is we can do a little bit of math, and we can say 0.12 plus 0.08, 12 plus 8 is 20, so that's 0.2, plus the probability that x is equal to negative 10 is 1, and 0.2 plus what value is 1? So 0.2 plus what value gives you 1? Yeah, 0.8. So our final probability is 0.8. Any questions? Any questions on how I computed the final probability, the probability that they're going to leave without purchasing? Any questions? Okay, so the next step is to create what's called a probability distribution table. And that's just a table of values. And sometimes you put it in rows, sometimes you put it in columns. That just depends on what you want, what your spacing looks like. And for this kind of page, rows look pretty good. And the first row will be X, and the second row will be P of X. And the X values were 190, 290, and negative 10. The P of X, the probability of getting that value, probability of 190 was 0.12. Probability of 290 was 0.08. Probability of negative 10 was 0.8. Any questions at all on this probability distribution table? Any questions? Okay, so if there's no questions, let's move on. What we're going to do, we want to find out, is this a good job or not? I mean, just based on looking at these numbers, do you think the salesperson, the car salesperson, will make money? What do you think, just by looking at it? Or is it a money loss? Any thoughts? So what do you think? Do you think there's going to be money made or money lost? I don't see y'all jumping in. It's hard to just look at it and see, but something, right? And you would care. I mean, if this is a job you're looking to do, maybe it's your business or whatever, then you want to make sure you're making money. Now, you're not going to make money every time for every customer because most of the customers don't buy a car. But when you do have a customer that buys a car, you make a lot of money. So the question is it worth it? And what you want to say is not imagining one customer. That doesn't do anything for you. What you want to say is that if you're in this position for a long time, what's going to be what's going to be around the average amount of money you make per customer? Any questions on the idea of that? Okay, so it's really important that this has lots and lots of good applications, and this is one of them. So it's called the expected value. And here's a template for how you interpret the expected value. If many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Any guess on why I said those words so loud? Any guess? Wasn't an accident. Why do you think I said it so loud? Emphasize, but in particular, if you don't use those words, you're going to lose a lot of points. Okay, so on any of the problems I grade, where you have to interpret the expected value, the word many, the word likely, the word average, and the words close to must be in your interpretation, or you lose lots of points. And just let you know, AI won't use those words. So if you just use AI to do all your work, no, you lose a lot of points. Okay. So, and we're going to do this a lot in this class. It's one of the ways I keep you from just using AI without learning. So you have to use those words. Got it? Take notes, whatever it takes, so that you get that down. Any questions so far? Okay, so now I some people will write EV for expected value, but it's an average, right? Right? It's not the exact average that you're going to get with, doing 100 customers, but there is an average involved in it. So we're going to use the letter mu that we use for mean. So we tend to use the same letter, and because it's an average. And the formula is a summation of x times p of x, but you're not going to have to use that formula much, but I just want you to get the idea. How do you think we're going to find the expected value and the standard deviation, by the way? Any guess? Here's our table. Any guess on how we're going to find the expected value and standard deviation for this situation? You're not guessing? We're going to use a calculator. And by the way, you're required to use a calculator. Do not use formulas that I don't even talk about in the webinar for the standard deviation. You're going to use a calculator. So what calculator number do you think we need to use? Again, I do things in order, but it should be obvious. I tried to make it obvious. Yeah, number 7, expected value, and standard deviation. I did everything I could to make this calculator really easy to know what to use as long as know what you're doing. So I click on expected value and standard deviation, and here's what it says. Enter the outcomes and the probability of that outcome occurring, and then hit calculate. Leave the bottom rows that do not have any values blank. And do not include commas in your entry. That's important. So if the X value was, 20,000, don't go 20, comma 000. It's just 20000, or the calculator has troubles. That's computer stuff. So I put my X values in. The first X value was 190. Probability was 0.12. So I can go 190 and 0.12. The second was 290 with 0.08. And the third was negative 10 with a probability of 0.8. Any questions at all on typing the values of X and the value of probability of X? And so making your own table, making a table in the calculator. Any questions? Okay. And by the way, for our class, you're never going to have to do more than this amount. I think I have 10 or something. Yeah. So, I'm not going to waste your time. If you had to outside of this class, then there's other calculators that'll do it, including the spreadsheet one. And you calculate. And there's the expected value. The expected value was 38, and the standard deviation was 98.4683. So 98.46, so 8383. And the expected value was 38. Any questions? Any questions on how I got the expected value and the standard deviation for this example? Okay, make sure you practice. Okay, even if you understand what I do, make sure that you figured out how yourself too. Okay, so now we interpret it and we got to make sure that those words are in there. So here it is. If many customers come and test drive a car, then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. Any questions on the interpretation? So what is it? You think this is a good job or not? How long do you think it takes to, work with a customer and have them test drive and then negotiate? How long do you think that takes? And that's not a math question. I don't know. I don't know. I'm not a car salesperson. But if it takes, let's say, a half an hour each time on average, then if you are working at this job for a long time, you're going to have two of these for every hour, or about $76 an hour. Okay, not terrible money. Any questions on that idea? Okay, but it's not going to be every customer is going to be, you're not going to make $38 for every customer. In fact, no customers result in a profit of $38 because in our values of X, we only had 190, 290, and negative 10. It's likely to be close to $38 if you have many customers. That's what the average is likely to be close to. Any questions on that idea? Okay. The standard deviation, by the way, is 98.47. And that's a pretty big number, isn't it, compared to the expected value? So that's a high standard deviation. So there'll be times when the salesperson's not making money for a while. Does that make sense? So that's the kind of thing after seeing the expected value, it might be a good job in terms of money wise. With the standard deviation, there's going to be good days and bad days. So you got to make sure that if you're the salesperson, make sure you got money in the bank. So the bad days, you can still afford food and stuff. Do you see? When you have a big standard deviation, that's what that tells you is that this 38 does not mean each customer is going to be anywhere near 38 typically. It's going to be far from it, including negative values. Any questions at all on this example? Okay. I'm not sure. Any of you from Tahoe? Any of you in Tahoe? I don't know where y'all live or where you are. You're not answering. You don't have to answer, but I was hoping to find out. Okay. What's one of the big things with expected value in Tahoe? Any thoughts for our economy? It's not car sales, by the way. We do have a little bit of that, but what's a much bigger thing? Tourism, but what type of tourism for expected value? It's a Tahoe thing. Skiing, that's possible, but that's not quite as important because that one you kind of know how much it costs and they just, everyone buys a ticket or whatever. Okay, I'm not seeing it. Casinos, the gambling. Yeah, the gambling. So, why do you think you would care about expected value? Let's say if you were working at the casino or if you were gambling at the casino. Why do you care about expected value? If you want to gamble at the casino, yeah, you're going to win or lose, and not each individual hand, if you're playing cards, for example, but over the long run. Okay. And do you think I ever made money on that? Any guess? The answer is yes. So when I was turned 21, I was able to do a lot of analysis on blackjack, it turns out, and I was able to get the best strategies for winning with card counting. And I ended up with a positive expected value. And I play for hours at a time. So many, many, many games, many trials. And I was always real close to the expected value for my profit. And it was always positive. Pretty much money too. Okay. But then when I got here, I got a call from the casinos. They had me work for them so that I could help them change their rules so that the expected value is negative even if you're a card counter. Just let you know. So the expected value is really important in the casinos. Any questions on this example? Okay, here's one more example. Okay, so now you're offered a life and dismemberment insurance policy. Costs $1,000 a year. The policy pays the heirs $100,000 in the event of death and $50,000 in the event of dismemberment. If you don't know the word dismemberment, that would be like having your arm chopped off. You don't die, but it sucks, right? Okay. The actuaries are the mathematicians basically that work for insurance companies to figure out what the expected value is. That's one of their main things. Okay. Have determined that you have a 0.3% chance of dying this year. Okay. Very small chance. And a 0.5% chance of dismemberment this year. Find the expected value in the standard deviation. Interpret the expected value and explain why the standard deviation might indicate it still might be a good idea to purchase insurance. So the first thing is, just like the last example, you look at the profit, and we have it costs $1,000, but if you die, your heirs get 100,000, so that's 99,000 in profit. And there was a 0.3% chance of that happening. Move the decimal over two places and you get 0.003. Any questions on that basic math right there? Okay. Similarly, if you have dismemberment, you get 50,000, but you paid 1,000, so it's 49,000 in profit. And if you didn't die and you weren't dismembered, then you paid $1,000 to the insurance company and you get nothing out of it. So that's going to be a negative 1,000 for your profit. Any questions on that? And again, 0.5% chance is 0.005. By the way, if you add these up, 0.003 plus 0.005 is 0.008. 1 minus 0.008 is 0.992. Was that too fast, or are you following what I just did? It's very similar to the last example. Any questions? Okay. So then it's time to put it in the calculator. We have 99,000.003. And I'm going to just hit refresh. That's the easiest way. So 99,000, no commas, 0.003. Then we had 49,000.005, 49,000, and then 0.005. And then we had negative 10,000.992. Any questions on that? And I hit calculate. Question about the 10,000? Oh, it was 1,000. Ah, it makes a big difference. Thanks. I think it was 1,000, right? Yep. One extra zero. Let's hit calculate again. There we go. All right. Expected value is negative 450. Standard deviation is 6,495.96. Go to the nearest penny. Not that anyone cares about pennies. So EV was negative 450. And sigma, standard deviation, 6,495.96. Any questions on that? So what we can say, I'm just going to say it instead of type it, is that if if many people purchase this insurance policy, then on average, it is likely that the average amount of profit per person or loss per person will be close to $450. Okay, so is this a good purchase? What do you think? Is a policy you should take or not? Let's see, y'all jumping in. Okay. The answer depends. Okay. It really depends on how disastrous it will be financially if you die or if you're dismembered. So for example, if you're in college and you're 20 years old, you don't have any children and no dependents or anything, and you die, no one needs money because you don't have children or you don't have anyone that needs your money. So having a negative expected value may not be a good thing. Does that make sense? On the other hand, if you have children, okay, or if you have someone who needs you for money, then it's a disaster if you die financially. And notice the standard deviation is really high. Is that clear? Okay, so for the insurance company, it's always going to be a negative expected value for for the person who buys it. Otherwise, the insurance company doesn't make any money and they're a business. Okay. So the big question is, do you really need insurance or not? And it has to do with how disastrous it will be if that horrible thing happened. This is one of those you hope you lose money. Certainly don't want to die, and you certainly don't want to be dismembered. So and you want to lose money on insurance. Any questions on this example? Okay, now we're going to move on to a very special type of discrete variable, and that's going to be binomial. And here's the definition. A binomial distribution comes from multiple independent trials with a yes/no question and measures the number of yes answers. Okay. The words don't have to be yes or no, but it has to be two choices, and you'll call one of them yes. That's a binomial distribution. Any questions on what a binomial distribution is about? All right, so here's something that is very important. And this I actually researched. Okay, so this is true. There have been 175 years in recorded history of global temperatures. Okay, so before that, we didn't do it. We didn't have the technology or whatever. Um, but for the last 175 years, we have looked at the global temperatures. Okay, the average temperature on Earth, basically. Okay, approximately. Okay, in the next 20 years, if the weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 175 years. Okay? So note this is an example of binomial distribution because each year you're going to say, is this in the top 10? And the answer is either yes or no. And you're looking at 20 years of it. Do you see that? Any questions on that? All right. So now what we're going to do is we're going to take these sentences, and this is sometimes the hardest part of the whole class, is to take a sentence and then figure out what it all tells you. So first thing is we're looking at 20 years. That's the sample size. Remember, sample size we always use the letter N for. Any questions on that? So N equals 20. Any questions on that? Okay. Then we're going to say, what is the probability of the answer being yes? So the question is this in the top 10? And the probability of it being in the top 10 will be 10 out of 175. Any questions? Any questions about how I came up with those values? Okay, now we need to find the probability that this will happen. Okay, any guess on what we're going to do next? Any thoughts? So what's the next step? What can we do to find the probability? Yeah, we go to our calculator. Okay. And you are required to use this calculator, by the way. It's online, it's free. And just note AI won't use it. So you need to use this one. So I can go back to the calculator menu. And what calculator number should we use? Should be obvious. Yeah, number 8. Okay, as I mentioned, I do things in order. We just did number 7, now we're on number 8. Binomial probability, because we're talking about a binomial distribution. We want a probability for it. So I click on binomial probability, and it asks for the low, the high, trials, and P. So what is the low? What's the least number of years of the last 20 years that could be in the top 10 for a random sample? And this should be very obvious. Not one. One's not the least. It's zero. If the last 20 years were cold, then none of them are in the top 10. Do you see that? Does that make sense? So the low here will be zero because that's the lowest number of years in the top 10 that could happen. And that is none of them. Okay. The highest, now this is going to, you might guess 10, but it turns out it's 20 because it's each year, and you look at the past 175 years. So if the years got warmer and warmer every year and you started with the highest, then they're all the highest. Do you see? So that's 20. Trials is our N, that was 20. P is a probability, and that is 10 over 175. And by the way, there's a scientific calculator. You can go 10 divided by 125, and you get 0.08. Any questions on that? Did I get it right? Oh, it's 175. I made a mistake. You didn't catch me on that. There we go. 0.05714, etc. Okay. 0.05714, dot, dot, dot. So now I can go to the calculator and I can just put them in. The low is 0. The high was 20. Number of trials was also 20. And the easiest is just copy and paste this number instead of having to retype it. Copy it, paste it into our P. Any questions on that? Wait just a minute. So low is 0, high is 20. Each time you have a point, I don't think it's 0.05. Let's see. 0.0, yeah, it's 0.05 for each time. Ah, that's why it's not 0. So let's read the question again. Sorry if I made a mistake. If the weather is random, find the probability at least 10 of them. So that should be 10. That's better. And we get a calculation and it gives you 0. Okay, and that's like to a bunch of decimal places. And it rounded to like 10 decimal places or something. Probability is 0. Okay. Just to note, does that mean it can't happen? And this is kind of what this class is all about, to be able to make decisions and understand what you're going to be, your conclusions are going to be. Any thoughts? Okay. What it means is it pretty much can't happen if this assumed randomness was correct. What that tells us is we didn't just have warm years because of random chance. We had warm years because something changed. Okay, and this is scientific, clear evidence that we're in climate change. Okay, so this is how scientists work. Okay, they look at the statistics, and if you get something that's that low, then there must be some assumption you made that isn't correct, and it's the assumed randomness. So it's something is going on that is making it so that our climate isn't just random. Things are changing because of something. And by the way, the next thing you do is then you look at all the possibilities and seeing which ones have are happening. And the only thing we have found that could actually make this happen is the atmosphere changing. This is how they determine there's climate change. Any questions on that? Do you see how important this is? Okay. But a lot of people, they don't know enough statistics and maybe they don't believe it, but that's because they haven't been educated. Okay. This isn't some, religious mumbo jumbo. This is education and this is science. Science uses statistics to make conclusions. Any questions on that? Okay. So we are in climate change and it's not because of randomness, something that went on. And that something, it turns out there's nothing else that it could explain it except the atmosphere. Any questions at all on that? Okay, let's look at another example. 20% of people worldwide feel lonely. Okay, sorry if you're one of them. If 17 randomly selected people are surveyed, what's the probability of that? Okay, so we're doing a bunch of these because I want you to get used to the wording and not just this exact wording, but understand how to look at this. So if it's between 5 and 10 of them feel lonely, what's the low? Hopefully this is obvious. What's the low? 5. What's the high? Also should be obvious. 10. Number of trials was 17. That was the sample size. And P was 0.24, well, 24%. Any questions on that? 5, 10, 17.24. I'm going to refresh. So 5, 10, 17, and 0.24. And there's our calculation. About a 38.75% chance. Any questions on that? All right. How about at least 6 of them feel lonely? What's the low? 6. What's the high? Not 24. That's the percentage of people worldwide. It's 17, because that's the number of people that we surveyed. So the most you can get is all 17 say yes, I feel lonely. Trials is also 17, and P is 0.24. And we can easily do that, 6 and 17. We just change these numbers to 6 and 17 and hit calculate. Get about 20.49% chance, or 0.2049. Okay, fewer than 5 feel lonely. What's the low? What's the low? Not 1, not 5. What's the smallest number less than 5 that could feel lonely? 0. What's the high? So what would the high be? Okay, this is why I did this one, because most people make mistakes. Is 5 fewer than 5? 17 definitely is not fewer than 5. What's 4 is the biggest number that's fewer than 5 for number of people. Any questions on that? So a lot of people make that mistake. You got to read the wording. And trials is 17 and P is 0.24. So 0 to 4. And we calculate and about 61.21%. How about exactly 5 feel lonely? What's the low? Yeah, 5. What's the high? 5 again. And same 17 trials, and the P is 0.24. So now we're going to go from 5 to 5. And you get about 0.183 or 18.3% chance. Any questions on this example? The wording is really important to be able to read the wording and come up with the low and the high. It's kind of one of the biggest mistakes people make is not reading the wording right. Okay, so next is continuous distributions. So we talked about what it meant. You can't you can't draw a probability distribution table. Can't do that, but you can draw a picture. This is kind of the most common one. What's the shape of this curve? Very important for you to know the shape. What's the shape of this curve? We talked about this in week 1. Nobody remembers? Very important. It's the most important. Okay, it's a normal curve, normal distribution. Okay, so just know that if you want to find the probability of being between two numbers, like between 1.8 and 2.75, it's the area under the curve above the x-axis between those two values. Now, for this example, if you had to do this by hand, you would cry. And you won't have to for this one. Okay. But I just want to let you know it's the area between the two values under the curve. Okay. What area do you know how to find? The area of what? What's like one of the easiest shapes? Whereas this one's not easy. What shape is easy to find area of? Any thoughts? Something you know, you've known it for many years since you were a kid. Think you get it in middle school. So what shape do you know how to find the area of? It's the easiest. Don't see y'all jumping in. As I say it, you'll agree. Okay, I don't see it, so I'll tell you. A rectangle. How do you get the area of a rectangle? Who remembers the formula for the area of a rectangle? Not a trick question. It's very simple. So what's the area of rectangle formula? Don't see y'all jumping in. All right, I'll remind you. The area of a rectangle is the base times the height. That's it. You just multiply those numbers. Okay, very important. So what we're going to be looking at for chapter 5 is distributions where it's not like this normal distribution. It's all curvy and tough, but it's a rectangle looking thing. So that's going to be called a uniform distribution. So a uniform distribution from A to B, where A is a low and B is a high, is a distribution such that at any two given intervals of length k, whatever that length might be, that is contained in AB has the same probability of occurring as any other interval. Okay, and outside of AB has zero probability. So the distribution curve is a rectangle. And this is important. This is the first time you're going to see this. We're going to have this more with other examples, but today this is what we're going to see. X is the variable. This little guy here, a lot of people don't even know how to say this. The way you read this is tilde, and that is on every keyboard. Okay? And what it means in statistics, it means has the distribution. So X has a distribution that is uniform. U for uniform. With lower bound A and upper bound B. Any questions? So if I say write down the distribution, this is what you're supposed to do for this chapter. And you're supposed to figure out what A and B are, of course. Any questions so far? Okay, let's do an example. Let's suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So the way you write this in symbols is X. That's the time they spend. Tilde means has the distribution of. U for uniform. 10 for the low. 120 for the high. Any questions on taking the sentence and turning it into those symbols? Okay, a randomly selected student who used a math tutor is observed. Find the probability that the student will spend between 30 and 70 minutes with the tutor. Okay, so it's going to be a step-by-step process. First thing is we have a uniform distribution, means we can draw a rectangle with the low at 10, the high at 120. We need to find the height of this rectangle. Any guess on what the area of the whole rectangle has to be, given the area's probability? What's the area of the entire rectangle? The hint is it's very simple. Very, very simple to type. I don't see y'all jumping in. Okay. All right. Remember, this is a uniform distribution. You can only be between 10 and 120. So you have a 100% chance of being between 10 and 120. So that's a probability of 1. So the area of the rectangle has to be 1. So now I can write area is the base times the height, and that equals 1. The base will be the high minus the low, 120 minus 10. That's how far it is from 10 to 120, is 120 minus 10. The height I called h, and I get this equation right here. Then I take 120 and minus 10 is 110. So 110 times h is 1, and I divide by 110. H is 1 over 110. Anybody lost? Anyone lost on what I just did? Today, unlike most days, today there's actually a little algebra to do. And we're going to have more too. Okay. So now we want the probability the student's going to spend between 30 and 70 minutes. So now I'm going to draw the rectangle and shade in the part between 30 and 70. That'll be its own rectangle, and I want the area of this rectangle. That's the base times the height. So the probability of being between 30 and 70 is base times height. For the base, you say, how far is it from 30 to 70? That's 70 minus 30. The height we calculated was 1 over 110. So I put 1 over 110. And that's 40. 70 minus 30 is 40 over 110. I could put it in a calculator if I want, but just I'm going to leave it as a fraction. I could write it as 4 over 11 if I felt like it too. Any questions on answering this question? Any questions? Okay. Again, always feel free to ask questions. That's what big part of this webinar is supposed to be me answering your questions. Okay, now comes part B. Find the first quartile for the time that students spend with a math tutor. Who remembers what it means to be the first quartile? Q1. What does that mean? It means 25% is at or below that number. So I'm going to draw a picture. And now I can say, here's our rectangle. We have our height, which was 1 over 110, by the way. We have our 10 and 120. That was the low and the high. We want to find the first quartile. That's a value of x. It's not a probability. We don't know this value of x. What we know is that there's a 25% chance of being less than x, or 0.25 is the area between 10 and x. Any questions on how I was able to use this picture and kind of see that? Okay, so now it's trying to use the area formula. Now the area is 0.25, but that is base times height. The base is the high minus the low, that's x minus 10 will be the base. The height was h, which was 1 over 110. And remember, that's equal to 0.25. So now we have to do a little algebra. So when we have a times 1 over 110, it's easiest to just multiply left and right by 110. And you get x minus 10 equals 0.25 times 110. So we multiply by 110. I want x by itself. I have x minus 10. I need to add 10 to both sides. So I get x equals 0.25 times 110 plus 10. And that's the answer. And you can do this. You can always pop it in a calculator if you want. I'll just stick it in the Google calculator. And that's 37.5. Okay. And what I recommend is going back at the picture and seeing if that looks reasonable. And I think it does. 37.5 sounds about right, so that there's 25% less and 75% more, because it's a lot longer to get to 120 from 37.5 than it is to get to 10 from 37.5. Which makes sense because 25% on the left, 75% on the right. Any questions on this part? I do want to give you that big warning. It's a lot easier to watch me do it than to do it yourself. But you want to practice some. All right, so now let's look at this one. A statistics instructor will be giving extra credit to the students in the top 8% based on how long they spend with the math tutor. At least how long must a student spend with the math tutor to get extra credit? You have to be in the top 8%. So in this one, if you're in the top 8%, then there's 92% less than you. So 92% is the area to the left, and that's base times height. And it's very similar. It's the same x minus 10 times 1 over 110. We still don't know x, but now instead of 0.25, we have 0.92. And I do the same algebra. I multiply by 110, and then I add 10 to both sides, and there I got it. And I get 92 times 110, 10 plus 10. I pop that in a calculator, by the way. I get 111.2. Any questions at all on this part? Okay. We do have some time. I always look to see if we have enough time to answer some of these others. Okay. All right. If you know the student spent at least 45 minutes with a math tutor, what's the probability that that student spent less than an hour with the math tutor? Okay. So now you know they spent at least 45 minutes. You want to find the probability they spent less than an hour. So this is a kind of probability from last week, and that is conditional. So we want the probability that now X is less than an hour, less than 60 minutes, and then given they spend at least 45 minutes, X is greater than 45. Do you remember this? And this had a formula. The probability of A given B was the probability of A and B divided by the probability of B. So that's going to be the probability of A and B to be less than 60 and greater than 45. You're between 45 and 60. 45 is less than X is less than 60. And then you're going to divide by the probability of B. That's the probability that X is greater than 45. Any questions at all on how I came up with this expression given that sentence that was asked? Because that's often very hard for people, is to read that sentence and turn it into a probability formula. Okay. For time reasons, I think I'm not going to do both of these, but it's kind of the same idea. Um, this is finding a probability, not finding an X. So maybe I'll do it a little bit. So this is going to be the top will be the base times the height. So that's going to be the base will be 60 minus 45. And the height was 1 over 110. And then we're going to divide that by the probability of being greater than 45. So greater than 45, that is going to be 1. So now if you look at this, to be greater than 45, that means you're over here. If X was 45, 120 minus 45. Divided by 1 over 110. Any questions? You could pop that in a calculator. I don't think I'm going to waste the time. Any questions on how I came up with that? All right. So what is the probability? What is the probability the student spends exactly 25 minutes with a math tutor? I'm going to jump to that one. The hint is it's really easy. Because if you look at the picture, exactly 25 minutes. Instead of 30 to 70, it would be exactly 25. How wide is a base of exactly 25? You tell me? How wide will the base be for the picture of exactly 25? So here's 25 and it's exactly 25. How wide is the base? Whereas between 30 and 70 was 70 minus 30. Exactly 25. How wide is a base? It's not 15. The idea is the lowest you could be is 25 and the highest is 25. What's 25 minus 25? So 15 would be at most 25, not exactly 25. Do you see the difference? So the idea here is it's base times height. The base is zero. It's 25 minus 25. It's just zero. So the probability of it being exactly 25 is zero. When we have a continuous distribution, probability of exactly anything is zero. That's important to know. Any questions at all on the examples I showed you? I can't do everything, but any questions? Okay, so now when we have a uniform distribution, so let's look at this example again. How do we find the mean for a uniform distribution? And the hint is it's actually quite easy. I mean, it's not super easy, but it's something that you can kind of figure out for yourself without being told, possibly. How do you find the mean if we have a uniform distribution? Here we go. I'll jump in. Okay, 55. How'd you get 55, by the way? I don't think it's 55. What you want to look at is when you have a uniform distribution, it's symmetric. So the mean is the same thing as the median, which is right in the middle. How do you find the number that's right in the middle when the low is 10 and the high is 120? Okay. Close, it's 120 plus 10 divided by 2. It's the average of the two numbers, not minus 10. Does that make sense? So the mean is the average, which is add them up and divide by 2. So the formula here is mu is A plus B divided by 2. Any questions on that? Okay, the formula for the standard deviation, I'm not going to explain why this is the case, other than trust me. But I will tell you, it involves calculus. And in this class, we don't do calculus, but you can trust me. I've done calculus. I've proven it. The standard deviation formula is the square root of b minus a squared over 12. It's all inside the square root. Okay. One of the things that a lot of people make mistakes on is forgetting parentheses, not putting it all inside the square root, like the 12 is also in the square root. So very important that you get it right in terms of putting it in your calculator. You don't have to memorize any formula for this class because you're always allowed to, use a note sheet or whatever to see the formula. So I would write it down so you have it in front of you at least for the next few weeks because it's used. Any questions about the mean and the standard deviation formula for a uniform distribution? Okay, so here's an example. Okay, suppose that the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces. Okay, when I say suppose, it means I made it up, but we can suppose it. I tried to make numbers that sounded right. And that the number of ounces that students use to fill their bottles in the drinking fountain, so I fill my bottle. I also drink in the drinking fountain sometimes too, but here's the bottle. It's got water in it. is uniformly distributed also between 4 and 16 ounces. All right, you watch Thorn take a 2.5-ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? So I have a question for you. We're asked to find out whose water usage is more unusual. In this class, what statistic have we found that talks about how unusual something is? Put in the chat box, and the hint is it should be very fast to put in the chat box. So what have we used to show how unusual something is? You remember? This happened last week, so not too long ago. Maybe it was a week before, actually. So 2 weeks ago. You remember? Not seeing I'll jump in. It should be quick, so I'm not going to give you much time because it doesn't take long to type. All right, I'll tell you. Z. Do you remember Z? The Z score? The Z is a measure of how unusual something is. And there was a formula for the Z score, and that was Z was equal to X minus mu over sigma. Tells you how many standard deviations it is from the mean. Any questions on that? Okay, now let's compute the Z score for Thorn and the Z score for Preston. By the way, these were my students. And they said it's fine if I use their names from a long time ago, but statistics doesn't change. So now we go ahead and we need to find X, mu, and sigma so we can plug in. Thorn took a 2.5-ounce drink out of the drinking fountain. So Thorn's X is 2.5. Now, he just drank out of the drinking fountain, right? So now we go ahead, and for the drinking fountain, it's uniformly distributed between 1 and 8 ounces. So now, for Thorn, the mean is A plus B over 2. That's 1 plus 8 over 2. 1 and 8 ounces, 1 plus 8 divided by 2. And that was just 4.5. The standard deviation will be the square root of A minus B squared over 12. So the square root of 8 minus 1 squared over 12. And that I popped in my calculator. That I can't do in my head as easily. And I get about 2.02. So the z-score, we plug in 2.5 as our x. We plug in 4.5. That was our mu, our mean. And we divide by our standard deviation. That was 2.02. Okay, and I got approximately -1. Have I lost anyone on this idea? Okay. By the way, was Thorn an outlier? Was Thorn an outlier? Yes or no? Yeah, no, because the outliers have to be less than -2 or greater than 2. And -1 is between 2 and -2. So Thorn's not an outlier for sure. Now let's do Preston. Preston drank 5 ounces or filled the bottle with 5 ounces. So Preston's X was 5. Okay, Preston did a water bottle, and for the water bottles, they are uniformly distributed between 4 and 16 ounces. So for Preston, I take 4 plus 16 and divide by 2. 4 plus 16 is 20. 20 divided by 2 is 10. Just a note so you don't make mistakes. If you type 4 plus 16 divide and then divide by 2, it won't give you the right answer. You get a parenthesis 4 plus 16 and the parenthesis, then divide by 2. That's a common mistake people make is the parentheses. Okay. Preston's standard deviation is the square root of b minus a squared over 12. B was 16. A was 4. So 16 minus 4 squared divided by 12 and square root of the whole thing. And I got about 3.46. So then I just take Preston's x, which was 5, then minus Preston's mean, which was 10, divided by Preston's standard deviation, which was 3.46. And I got negative 1.45. Is that an outlier? It's not. But now let's compare negative 1 and negative 1.45. Negative 1.45 is farther from 0 than negative 1 is. So that means that Preston's water usage was more unusually small. Any questions on this idea and how I used all the formulas to come up with this conclusion? Okay, I do want to give you a heads up that just about everything we do in this class is a word problem. Whether you like it or not, it's just the way statistics is. It's all applications. So you have to be able to read a paragraph and understand what information it's given in terms of what to plug in for the numbers that you need to plug in. Okay? Formulas aren't that hard, but knowing what to plug in, that's usually the challenge and which formula to use. Any questions at all on this example and the uniform distribution and the mean and standard deviation and using it? Okay, so the next thing I want to tell you. So by the way, Preston's water usage was more unusually small. But the next thing I want to tell you is the secret word, and that is area. Because remember, for a uniform distribution, if you want to, or any continuous distribution, you want to find the probability. That's the area between the two values under the curve above the x-axis. So area is a good secret word to have. So area. So that's the secret word. Write it down, put it in the secret word. Remember, if you hear the secret word, you do the secret word quiz. You do not need to send me your notes as long as you do it by Sunday. Okay? But I strongly recommend taking notes anyway because it helps for learning. Any questions at all on any of this? Okay, so I do want to remind you the project is what you should be, a big focus is the project at this point. And make sure that you let me know what your idea is so that I can give you suggestions and help you so you don't have a disaster. Okay. And Peter, our tutor, is also happy to help. So make sure that you do, get the help you need and make sure things are working as you go along. Any questions at all on that? Okay. If there aren't questions, then I think I'm going to call it a webinar. And I am going to stop the recording. Thanks for coming. But I'll always be happy to answer questions after too.